Summer in Pisa and everyone wants to see the Leaning Tower and of course offer it a little bit of support. The famous bell tower doesn't lean as much as it once did thanks to substantial engineering works. It may be good for another 200 years, but that doesn't mean the conservation work stops. The new tool in the Conservators' arsenal is 3D scanning, which can precisely map every stone of a building and provide the ultimate reference manual for future repair works. Rescan periodically, and any minute movement in the building's stones should be spotted. But what wasn't possible to scan until now was the interior of the tower because of its tight, spiralling stairways. So we've climbed almost 300 steps to get up here to the top of the Tower of Pisa, and this is the device that they're using to scan the inside of the tower. It's called Zebedee, after the famous children's TV character, because like Zebedee, it's got a bit of a spring in its action. This prototype device is designed by Australia's National Science Agency. It oscillates from side to side around once a second, sweeping the walls, floor and ceiling with its laser. It uses the physical landscape around it as its reference point to build a 3D visualization in record speed, however tight the space may be.
Other systems, you have to set up tripods, they take a lot longer to scan, you have to move your tripod from place to place, and it really just takes a lot longer. With this system, we can walk around and we can map the world in the time it takes us to walk around.
3D scanning isn't just for the conservationists. We can experience the Tower of Pisa in all its full 3D glory in this virtual reality cave, which enables me to skirt around the tower, even to fly through it. The cave belongs to a local university which is collaborating on the project. They hope the data could be used to create interactive experiences for visitors to Pisa.
With a 3D model, actually you can fly, you can go virtually anywhere you want, and you can finally appreciate the kind of subtle details that are actually all around, but you will never see in reality because you will be stuck to the ground.
Museums using novel technologies to attract more visitors is nothing new, but 3D visualizations are now enabling them to display exhibits that otherwise may have been lost in a basement somewhere. This is London's Science Museum's shipping exhibit. It closed its doors last year, but it's now been given a new lease of life on a virtual shelf on the museum's website.
Over 5 nights in 2012, before the gallery closed, 275 laser scans were made and 2 billion precisely measured points were preserved by these lasers, which could be turned into essentially a point cloud of this historic exhibit which had been here for 50 years.
London's Petrie Museum was an early adopter of 3D scanning technology. It started scanning its collection of Egyptian artefacts more than 6 years ago. Scans were then used to create these apps so that visitors to the museum could do a bit more than look at a glass display. They can have a virtual play as well. But it's not just about engaging visitors. 3D is quickly becoming an important tool in archaeological research too. These little figures, called shabtis, are commonly found in ancient Egyptian tombs, servants for the deceased in the afterlife. Petrie Museum in London has long had them in their collection, but what wasn't possible to tell till now was whether the figures were individually crafted or mass-produced.
What 3D scanning allowed us to do was to look at the object beneath the design, and that's where we see this evidence for mould usage and also potentially mass production of these shabtis, which is very important from a research point of view, because whereas with the design you may think that you have maybe a shabti that was made entirely by one person, an artisan if you will, if you've got mass production of a typical shabti body, you almost have maybe a production line industry within ancient Egypt that could help develop our notion of Egyptian economy.
3D scanning also means that these fragile relics can be multiplied using 3D printing. Many collections of archaeological finds are scattered in different museums around the world. Now, uniting these collections is as simple as pressing print.
Other museums could do the same thing eventually, and you could see the whole find together again for the first time, and that would give you a unique insight into what that location was about, what that dig was about, who lived in that tomb. So that's really exciting, and having a digital replica that you can print almost instantly on a 3D printer then gives you that opportunity to bring masses of objects together and you can see them again.
And should an artefact become damaged, 3D printing can be deployed to create precise replacements. These are 3D scans of the lion sculptures at Blenheim Palace, birthplace of Winston Churchill. These 3D measurements could be now fed into a stone-cutting machine, a new, near-identical lions hewn robotically. Back in Pisa, Jonathan Roberts and Zebedee have moved on to the adjacent Camposanto Monumentale, a medieval mausoleum badly damaged in Allied bombing raids during the Second World War. Of course, science is no stranger to Pisa. This is the birthplace of Galileo. You can't help thinking he'd have approved of the 3D laser scanners walking about his old hometown and helping to preserve its wonders.